Hi everybody. In this video we're going to solve the language problem in physics and the rest of science, which has been holding humanity down a scientific dead end for centuries. It's a simple language problem and one that we've known about for about 30 years. People started to think maybe we've got all the pieces of the puzzle, but we can't see what we're doing. We can't see the wood for the trees. I'd like you to listen to a radio program in our time, Quantum Gravity, Dr. Jan Levin and Professor Lee Smolin saying this is going to happen. We think in language. So if we can't say it, we can't understand what we're thinking. Laws of physics are inconsistent. They couldn't be presented in a court of law as truth. But all the mathematics is correct to unprecedented accuracy. All the science, the physics, the experiments are verified to unprecedented accuracy. So there's only language left. Now, I used to go through court cases looking for language problems. And when you look at physics, the problems jump out at you straight away. There are three different kinds of physics based on three different causes of action. When we study all the same matter in the same universe, how many causes of action should we have? One. Gravity jumps out at you as a red flag straight away. It's the only member of general relativity. It's the only part of science where cause of action is curvature of space-time. It sits all by itself. So the Earth's magnetic field has a different cause of action from the Earth's gravitational field. It's inconsistent information. They must be unified. So if we look at the language curvature of space-time, that doesn't tell you what gravity is. That just tells you that space curves and time, the clock is connected to space. But what about the curvature of the Earth? We need to change the language. Gravity is the fact that space is curved by the Earth is curved into a sphere by space, which means they can communicate. They can have a relationship, and any relationship requires the exchange of information. So if we take out the word space-time and replace it with the exchange of information, we then get a description of the Earth and its gravitational field, which makes sense. And does that unify the Earth as a magnetic body with its magnetic field and unify those with gravity? Well, yes, it does. It's just the same. So now Einstein has taken out gravity as a force and said it's the connection between physical matter and space. We'll just do the same thing with magnets. Magnets cannot apply a force to another magnet without touching it. Now, here's a little diagram. It's a little picture of compasses placed around a magnet. And as you see, the compass needles line up with the field, not the magnet. There's no attraction or repulsion. There's an alignment with the density and the direction of the field. Problem solved. So when magnets click together in a line, they're not attracting each other. They're aligning with the density of the field and the direction of the field at the poles. We've done it. And it's now unified with gravitational body and fields, and we just need to now include the Earth as an electrical body and its electrical field. Easy. We just use the same fix again. The exchange of information between bodies and fields. And what we see is two little patterns. One pattern is a 1, 2, 3 pattern. One centre of gravity, two poles, three electrical vectors, what used to be called the right-hand rule. And the left-hand rule, generators and motors. I can't remember which is which at the minute. If you know, drop us a line in the comments. 1, 2, 3 pattern. We're going to see that again. And the other pattern is electricity and magnetism generate each other, a related pair, working with the unique partner, gravity. That pattern shows up in every field of science. Shows up right at the base of quantum mechanics in a proton, the simplest system in the universe. 2 up quarks and a down quark. And then a neutron, 2 down quarks and an up quark. And then the charge is just the same. And then the whole of the periodic table, neutron, proton, electron. So we've now got general relativity unified, complete, as the 3 different relationships between physical matter and space. We've got a pattern, a blueprint, with which we can rearrange the standard model of particle physics into pairs and triplets. And we now need to unify quantum physics with classical physics. That's all of it. So can we use the exchange of information as cause of action in quantum physics? Well, cause of action in quantum physics is the exchange of bosons, a little unit of information. So we've done it. So now we can bring general relativity into the standard model in the same pattern as everything else. Here it is, the new standard model. And it's not finished. We've got to bring in the Higgs boson, but we can't have it sat in a model by itself, or the photon when everything else is partnered off. The photon's easy. Neutrinos and electrons, which are the switching mechanisms that switch protons into neutrons, so you can build all the elements. And that little pattern, 2 and 3. Why 2 and 3? Well, they're the first 2 prime numbers. The atoms of arithmetic, the building blocks of mathematical units. And it's very important to see that the building blocks of matter, the elements, before you can make the first composite element, you've got to make deuterium and tritium. And when you make deuterium, that switch spits out a positron and takes away 1 unit of electrical charge, and it also spits out a neutrino, because I've got to change 1 quark from up into down. So there's a relationship between 3 different coloured quarks and 3 different kinds of neutrino. But we've called the neutrinos electron, the muon and the tau, not red, green and blue, so we miss the connection. A language problem again. Then the photon, that gets spat out when you change deuterium into tritium. So again, I get a little 1, 2, 3 pattern, which just shows up everywhere. So now we've got the standard model, consistent and almost complete, but we're nearly there. It's 90% finished. It's just like the periodic table. There were a few holes when we first drew it up, so you look for the bits. Now we can lay out the laws of physics as they should be. And what we see, a perfect symmetry between what happens at the atomic scale and what happens at the classical scale. So here it is, a beautiful chart with the symmetry between quantum physics and classical physics, both laid out on the periodic repeating pattern of pairs and triplets. So let's have a look at that. Classical fields. One centre of gravity, two magnetic poles, three electrical vectors, reflected symmetrically in quantum field theory for the properties of mass, magnetic moments, which come in pairs, and electrical charge, -1, 0, +1, a triplet. And then we get classical waves in all the kinds of matter. Solids, liquids and gases. Any kind of wave in those. Now I'm not talking about exotic matter like neutron stars or bosons and condensators. I'm just talking about the regular matter that we deal with. And what about quantum waves? Well, I get three different kinds in the 1, 2, 3 pattern. Electron wave, singular, electron microscope, electromagnetic wave, and then a triplet, the neutrino wave, in 1, 2, 3 of symmetry. And then we get classical mechanics. Now here I can use the word force for physical against physical. Levers, gears and hydraulics, where I swap force for distance, rotational distance and area. And if I look at quantum mechanics, bits against bits, all the relationships between quarks, leptons and bosons. So this is what physics has to look like. Beautiful symmetry, periodic repeating pattern. We've done it, but we haven't finished. There's a missing part of physics, which Roger Penrose talks about. Something that hasn't been recognised. The physical behaviour of matter, all proved by experiment, which is not classical physics. It's called the laws of chaos. Now at the minute, nobody knows what to do with these. Are they physics? What are they? They're just sat on the shelf. But now we've changed cause of action to the exchange of information, we can bring them in and sit them beside physics as the missing part of physics. And I get a 1, 2, 3 pattern. I can have quantum mechanics sat by itself, a proton sat in space. Then I get a physical object, which has two kinds of physics, say a piece of wood, which is an object, and at the same time, all the quantum behavior in the atoms. And then if I make that into a chaotic pendulum, I then get the levers, classical physics, the arms behave as levers, and then I get the chaotic behavior and the quantum behavior. And the difference now is the relationship between the levers changes continuously. So the relative length of the levers is dynamic relative to each other. In a harmonic pendulum, the relationship is static. You can measure the length of the arm and determine the rate of swing, but not so with the chaotic pendulum. So I've got three different kinds of fundamental laws, all with common cause of action, and I've got consistency in physics. And that consistency now allows me to go on and look at the rest of science. All of biology is based upon the exchange of information and the numbers 2 and 3. Just look up the chemistry of photosynthesis and respiration. There it is. And carbon. All of life is based on carbon. The number 6, 2 and 3. 6 elements, 6 protons, 6 neutrons and 6 electrons. So this change is obvious once somebody said it. But just because it's now all consistent doesn't mean that your brain can accept it straight away. It's too unusual. And we don't like unusual. You've won the lottery. Your brain has already guessed it's too unlikely. So you say, I don't believe it. So you need plenty of acceptance time. A few nights sleep, look at this video again, repetition, very important. Speak to other people, establish a norm, try and throw it out, say what's wrong, say we should go on with science just being nonsense. And very importantly, it doesn't change the curriculum at the university. I'm not changing any of the science. It's the same stuff you already teach, just in different language. But now it's consistent and you can all speak to each other. At lunchtime, how important is that? And don't try and commit yourself to anything too soon until your brain has accepted it. Just say, I'd like to see it again. And that way we can all start again from scratch, a low level description of reality that's the same for everybody on the earth. At last, we can all stop talking nonsense. Thank you, and see you next time.